All right, welcome back. Week number 2. Happy Monday morning. One great notice. The construction people aren't here right now. So I'm going to go ahead and get started and we'll just live in peace for a while. So we're going to continue with Chapter 7. We're going to start 7.2. Still using the law of sign. But today we're going to talk about the ambiguous case. Well, what in the world is that? Do you remember when we talked in geometry and we had our side, angle, side, angle, angle, side, or angle, side, side, all those 4 we listed last week, okay? There was one triangle that we never talked about. Do you remember what that one was? Maybe you do, maybe you don't, but we're going to talk about angle, side, side. In the book, they call it side, side, angle. But if you remember, if it made that word, we could not use it in geometry because there was no way to prove 2 triangles were congruent using angle, side, side. But today in Trig, we're going to find out why that was not the case. Why that was the case in geometry, and how we're going to deal with it in Trig. Okay? So, if you have 2 sides and an angle opposite it. So if we know an angle A, okay, and we know a side length B, and up here is a point C, the side A that would be opposite angle A, okay, so we would have angle A, and we would have a side, and we might have another side that is side A. Okay, so B is down here somewhere. We don't know anything about angle C or angle B. Okay, so side A, there's 3 different options for what side A could be. Side A could simply be really short. Okay, would that make a triangle? So this would be your side A is really short. There are no triangles possible. Okay, it would not make a triangle. Okay, what if side A, let's go straight down. Oh, we're going to pretend that went at a right angle. Okay, then that would be one triangle would make. Okay, one triangle. Or even if it wasn't at a right angle and it went farther out, but it's still connected to this B. Okay? We would still have one triangle available. Okay? And last, we're going to try this. If this angle up here at C is very small, your A could be there, or your A could go out farther here and connect to the B out here. Okay? So this black piece, you could have an A here and an A here that are the same length. And that would make 2 triangles. Okay? It's all going to be about your angle B. Okay, if angle B is obtuse, right, or acute, will depend on how many triangles you will have. This is the ambiguous case. Okay, they have some rules, but they kind of don't make a ton of sense. So let's start looking at some possibilities. Okay. If you want to read the box applying the law of sines, it talks about sine theta if it's between 0 and 1 or bigger than 1. My brain doesn't always think like that, so I just want to start drawing triangles. Okay? If angle B is 55 degrees 40 minutes, side B is 8.94, and A is 25.1 meters. I just forgot my meters there. So if we were drawing this, I'm drawing a triangle, and I always just draw them the same as I always do, 55 degrees, 40 minutes, 8.94, and then A is, we'll put A up here, this A is 25.1 meters. So the question is, can we solve for A? Of course we can. We have an angle and a side opposite it. Can we solve for the angle A? So here we go, law of sine works. So we would put 8.94 over sine 55 degrees, 40 minutes equals 25.1 over sine A. Now this was different than the one we did before because the last time we were really just solving for side lengths. Your process is going to be the same. Oh, there goes somebody's phone in class. I'm going to cross multiply and get 25.1 sine 55 degrees, 40 minutes equals 8.94 sine A. We're going to divide by 8.94, divide by 8.94, and we get, when you plug all of this into your calculator, it comes out to 2.31, etc., 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 equals sine A. And remember, anytime you are solving for an angle, you're using the -1, correct? So when you go to plug in sine -1 of this number, this 2.3 number, to get angle A, are you doing that? Guess what you're going to get? That's right, an error. Because can sine have an output that's greater than 1? No, it cannot. It means the side A is too short and does not go and connect to the side length A. Okay? So since we got an error, that means no triangle exists. Okay? That's an answer. No triangle exists. You're done. You can't do anything else. So when it says solve for this triangle, you can't. It doesn't exist. Sometimes there'll be a question that just says, how many triangles exist? Your answer can be 0. In this case, it would be 0. But there are times that it might be 1 or it might be 2. Okay? Let's work one more problem. See, that one was in your book. You could follow along. Let's work one more problem. If I give you triangle ABC, and A is 17.9 centimeters. C is 13.2 centimeters. Oh, if you can read that, let me try that again. I was looking down. 13.2 centimeters, and angle C, the big C, is 75 degrees, 30 minutes. Can you see, solve this triangle? Does a triangle exist? Is the big question. So I'll let you start that problem. I hope you've done a little bit, so I'm going to go ahead and start. 13.2 over sine 75 degrees, 30 minutes equals 17.9 over sine A. I have to pull out my calculator. Actually, it's going to pull it up on my board because I left my calculator at my house. Imagine that. So when you cross multiply, you have 17.9 sine 75, 30 minutes equals 13.2 sine A. We're going to divide by 13.2. There we go. It's pulled up now. So when I plug this into my calculator, all together, close that, we're going to clear. 17.9 sine 75. Oops, I forgot the second one. 75 degrees, 30 minutes. Could I have converted that? I know it's 17.5. I don't know why I did anything different. Divided by 13.2. I get 1.31 equals sine A. I should know right now that this isn't going to work, but I'm going to try it just in case. And I should be in degree mode, remember that. Second sign, second answer. Error, domain. We cannot plug in sine where sine has an output more than one. So this would say no triangles exist. 0 triangles. Okay? So if that number, sine of an angle, sine theta, is greater than 1, you will not have a triangle. You can stop right there. You're done. Okay? Now we're going to go and look at some more. All right, if I give you angle A equals 55.3 degrees, side A is 22.8 feet, and side B is 24.9 feet. Solve triangle ABC. Okay? We're going to do the exact same thing that we have always done. Sometimes I like to draw a triangle just so that I can have it. You'll see on what I load for you for 7.1, I drew most of them. Okay? So if angle A is 55.3, I'm going to put it at the top. Then the opposite is 22.8. It doesn't matter where B is. I'm going to put it over here. 24.9. Here's B. Here is C. Okay? Still setting up the law of sine. So I have 22.8 over sine 55.3 equals 24.9 over sine B. Cross multiplying, I have 24.9 sine 55.3 equals 22.8 sine B. Dividing by 22.8, these cancel. This one's actually in my book. So this is a decimal, 0.897, etc., equals sine B. Yay! It makes a triangle, at least one. Okay? So when I plug in the inverse sine of this number, I'm going to get that it's 63.9 degrees is angle B. Okay? Now, once we get an angle, we have to check something. Okay? We have to check to see if its supplementary angle will also give us the same thing. Now you're like, what, Miss Evans? What are you asking? So I'm going to go over here to my thought bubble. I know you've missed my thought bubbles. I'm going to ask you to plug in sine 30 degrees. Okay? We all know what sine 30 degrees is. We could draw a triangle. 30 degrees is 1/2, correct? Yes. So now what is supplementary to 30 degrees? You all said sine 150. What do you know about sine of 150 degrees? You can plug it in your calculator. Plug both of these in. Sine 30 is 0.5. If you plug in sine 150, guess what you're going to get? The exact same output. Okay? So there's 2 degrees that I can plug in and get this decimal that we got. Okay? So we have to check to see, will it make a second triangle? Okay? So I'm going to close up my thought bubble right there. And I'm going to go to the side. And I'm going to take this answer that we got for B, and I'm going to find its supplementary angle. Okay? So here we go. I'm going to say, what is 180 minus 63.9 degrees? When we subtract that, we're going to get 116.1 degrees. Now, if you plugged in sine of 116.1, you would get this exact same decimal. Okay? That's why we're checking. But now we need to see, is this second angle, could angle B really be 116.1 degrees? We're going to have to check. Your angle A, we're looking back now to angle A. So I'm going to add, so I'm going to write possible angle B. I'm going to add it to angle A. Now angle A can't change. Okay, because angle A was given to you. It cannot change. But I'm going to add angle A to the supplementary angle. When I add angle A, I'm adding in my head, imagine that, I get 169.4. Okay? If 169.4, if the angles that you get, if they add up to be less than 180, you have two possible triangles. Okay? Let me say that. Maybe I will write it down. Okay, I'm going to scroll just a little bit. This is going to get very messy. Okay? If your supplementary angle, I'm going to put a star here. If the supplementary angle is added to the given angle and is less than 180 degrees, you will have two possible, actually no, you're going to actually have two triangles, not possible. Sorry, I'm taking that away. You will have, oh, how much did I erase? You will have two triangles. So you're going to have two answers, okay? So now that this has happened, I need to go back and label some stuff, because if I don't label it, it's going to get a little bit hectic. So now I'm going back to this first angle that we found, this B, and I'm going to label it B1, okay? Then I'm going over here to the supplementary angle, okay? I'm actually going to call it B2, okay? So now we're going to have a B1 and a B2. And guess what? We're going to have a C1 and a C2, angles and sides. So we will have to solve both triangles, okay? I'm going to go to another page. I'm going to keep these numbers with me, okay? So, I know it's a lot. Just bear with me. I'm going to write the given back up here again. Angle A was 55.3 degrees. Side A was 22.8 feet. Side B was 24.9 feet. We solved and found a B1. B1 was simply 63.9 degrees. Okay? Our B2 was the 116.1 degrees. Okay? I still believe that's what it was. Yes. Okay. Now we're going to have to solve independently of one another both of these triangles. So I will have a big C1. Okay? So that way I would add, or really I would subtract 180 minus 55.3 minus 63.9, and that will give me C1. Okay, when I subtract those, I get something like 60.8 degrees. So C1 is 60.8 degrees. I have all three angles. Now I just need little c1. Okay, I'm going to use the law of sine. I'm going to use 22.8 over sine 55.3 because that's my given, equals, now I'm going to use C1, this is not an equal sign, okay, C1 divided by sine 60.8, okay, when I cross multiply, same process, I'm going to get C1, little c1, is approximately 24.2 feet. Okay? If we are given the first triangle, we have our given information, angle A, side B. We found the other two missing angles and the side. We're done with that one. Okay? But now we need to go over and solve the second triangle for what if B2 equaled 116.2. So big C2 would equal, we would go 180 minus 55.3, because that angle's not changing, minus 116.1. And when we subtract those, we're simply going to get a very small number. It's going to be 8.6 degrees. Okay, well, you're going to have a very obtuse angle and a very acute angle. Okay, for little c2, we would do the same exact process. We're going to use that 22.8 over sine 55.3 equals c2 over sine of 8.6. Okay, it's probably going to be a really small number with that small of an angle. So C2, when you plug it in, when you cross multiply, plug that in, it's going to be something like 4.15 feet. Okay? You will have 6 answers that you will have to find when there are 2 triangles. Okay? I'm going to pause. I feel like that was a lot. Maybe I'll leave you. I'm just going to do another video. We'll do another one and finish this up, and then you'll have problems with this one tomorrow. Okay? Try to wrap your head around it. Maybe work this problem again. But we'll come back tomorrow and do some more. Bye.